Good day, my name is Andres Salmo, and I am majoring in Bachelor of Science in Electrical Engineering. Today, I'm going to explain to you my coursework number two, which is the summary of the lesson that was discussed last Tuesday. So, the things that you will learn in this presentation. Firstly, you will learn about the electromagnetic spectrum, uh, mainly the radio frequency band and the optical frequency band. And next, we have the wavelength and frequency, which are the two methods that are used in measuring the electromagnetic spectrum, and the types of communications media, namely wired and wireless, and how does the radio wave propagation works. So, electromagnetic spectrum. The electromagnetic spectrum is the range of all types of electromagnetic radiation that is measured either through frequency or wavelength. Here you can see an example of the electromagnetic spectrum that is measured in frequency. Here you can see the increasing frequency on the x-axis, and there are two separating bands that separates the electromagnetic spectrum in half. The first half is the radio frequency band. So what is radio frequency band? The radio spectrum, also known as the radio frequency, or RF, is one of such parts of the electromagnetic spectrum that overlaps our sub-terahertz range at its lower end. Accordingly, electromagnetic waves in this frequency range are called radio frequency bands or simply radio waves. RF bands spread in the range between 30 kilohertz and 300 gigahertz. Alternative point of view offers coverage between 3 kilohertz up to 300 gigahertz. All known transmission systems are operated in the RF spectrum range, including analog radio, aircraft navigation, medical radio, amateur radio, TV broadcasting, mobile networks, and satellite systems. You will learn more about these frequency ranges later on this presentation. Next, we have the optical fiber band. So here in the optical fiber band, the frequency gets massive, or it is large enough for us to measure. So instead of measuring it to frequency, we measure it to wavelengths. So what is a wavelength? A wavelength is the length of one cycle of the electromagnetic wave that depends on the frequency of the wave and the velocity of light. Mathematically, it is expressed by lambda is equal to k multiplied to c over f, wherein k is equal to the velocity factor, c is equal to the speed of light in free space, and f is equal to the frequency or hertz. So here is an example of the electromagnetic spectrum that is measured in wavelength. As you can see on the right-hand side, on the radio frequency band, it is larger. However, as it increases energy, the wavelength decreases. On the left-hand side, you can see that the wavelength is getting smaller and smaller. And we're going to explain that later on this presentation. So next is we have the frequency. The frequency is the number of times a current goes through its complete cycle per second. So in mathematics, it is expressed by F is equal to 1 over T, where T is the period. So here is an example of an electromagnetic spectrum that measures the frequency. You see the wavelength there at the top. So explanation for this is as the wavelength gets smaller and smaller, the frequency increases. And as the wavelength gets larger and larger, the frequency decreases. So frequency and wavelengths are inversely proportional. So here are the different band designations based on the International Telecommunications Union. So here are the different ranges of the electromagnetic spectrum and their respective designations. So between 30 to 200 hertz, we have the ELF, or the extremely low frequencies. Here in the extremely low frequency, uh, it is where with it is where AC power line frequencies as well as the low end of human hearing range is uh, being classified. Next, we have the voice frequencies, or uh, voice frequencies 300 to 3 kilohertz frequency range. So based from its name, this is the normal range of the human voice, although human hearing extends from 20 to 20 kilohertz. Most intelligible sounds occur in this range. Next frequency range, we have 3 to 30 kilohertz. 3 kilohertz to 30 kilohertz. So it is classified as the VLF, or the very low frequencies. In the very low frequencies, it includes the higher end of the human hearing range by up to 20 kilohertz, and many musical instruments also make sounds in this range. Next frequency range, we have 30 kilohertz to 300 kilohertz. And it is the low frequencies. Here in low frequencies is the range that are used in primary communication services such as aeronautical and marine navigation. Next frequency range, we have 0.3 to 300 kilohertz to 3 megahertz. It's classified as the medium frequencies. Here, the major application of frequencies in this range is AM radio broadcasting, and marine and aeronautical communications also takes place in this range. Next, we have high frequencies. These are frequencies generally known as short waves. All kinds of two-way radio communication take place in this range. Next, we have very high frequencies used by many services, including mobile radio, marine and aeronautical communications, FM radio broadcasting, and television channels 2 to 13. Frequencies above 1 gigahertz are generally known as microwaves. Next frequency range, we have the ultra-high frequencies, a widely used portion of the frequency spectrum, including television channels 14 to 83, land mobile communications, and cellular phones. Next, we have super high frequencies. These are microwave frequencies that are widely used for satellite and radar communications. So take note that when we reach the gigahertz range of the electromagnetic spectrum, it is mainly called microwave, since the waves on that range is getting smaller and smaller. Actually, they are micro in size, so that's why they are called microwaves. So moving on, we have extremely high frequencies, and only a limited amount of activity occurs in this range, including satellite communications and some specialized radar. So that's the end for the radio frequency band. Now let's move on to the optical fiber band. So the next frequency we have is the infrared. Infrared refers to radiation generally associated with heat. Infrared is used in astronomy to detect stars, remote control units, guidance of weapon systems, and optical devices. And lastly, we have the visible spectrum, generally referred to as light, used in various communication systems, fiber optics, and laser technology. That's why uh, visible light is the last one, because it is the limit wherein next, we have the very high frequency waves, which are ultraviolet, X-rays, gamma rays, and cosmic rays. So ultraviolet is basically not cool for humans. X-rays are used for medical purposes. Gamma rays, cosmic rays. Next thing we need to talk about are the two general type of communications medium, namely guided or wired, which uses of fiber optics, unguided or wireless, which is the principle of radio wave propagation, which explains the principle of radio wave propagation. Here in guided or wired, we use wires to send radio wave signals to one place to another place. And embedded wire or wireless for radio wave propagation, you can see in this um, image that radio waves can propagate from transmitter to receiver in four ways, into ground waves, sky waves, free space waves, and open field waves. Here we can see this tile. Here we can see there are four types of radio wave propagation. Based on this um, image, you can see that these four types are ground waves, sky waves, free space waves, and open field waves. Ground waves exist only for vertical polarization produced by vertical antennas when the transmitting and receiving antennas are close to the surface of the Earth. Meanwhile, skywave propagation is dependent on reflection from the ionosphere, a region of rarefied air high above the Earth's surface that is ionized by sunlight, primarily ultraviolet radiation. And lastly, we have the direct LOS wave, or space wave, or line of sight wave, where it is direct uh, propagation between the transmitter and receiver without relying on any without relying into anything like reflecting the wave to the ground or reflecting the wave to the atmosphere. So that's it. Thank you for listening.